Just to start, who's actually doing microservices in production currently? Who's happy that he's actually doing microservices? Who's not that happy that he's currently doing microservices? No one? So everybody's happy? Or you're somewhat happy? Okay. Maybe just a short introduction of myself. I'm Gideon. I'm a principal consultant at CBA, and CBA is a IT consultancy firm in the Netherlands. And basically what we do is, besides normal IT consultancy, we also do stuff like agile consultancy, infrastructure consultancy, so basically the whole spectrum. And the reason why we're doing that, or basically our main focus, is to help companies with their transformation or their digital transformation. It's a buzzword currently because I think every consultancy firm is currently doing digital transformation kind of things. But I think specifically in that area, having something like microservices can actually help a lot. And that's actually what I want to talk about today. So it's a bit less technical, I guess, than the other talks here currently at the conference, but I hope it has some value for you. So this is one slide which is mostly ending up on some kind of management pitch I do, and I think this is very important also why maybe you should implement microservices, at least for maybe companies which are already having some kind of IT stack, is that if you take, I think 7 or 8 years ago, most companies were competing with each other by just being in the same kind of area, being bigger than the other one, trying to push the other one out of their market space. But if you currently look at what customers of companies expect, is that most of the experience is currently driven by IT, right? And what you see is, like, for instance, if you have a bank like ING, which is a customer of ours, normally their competitors would be all of the other Dutch banks, and one of their biggest competitors currently is Apple with their payment provider and Google with their payment providers. And why is that? Is that both Google as Apple, can actually move very fast in terms of functionality, and the more legacy kind of banks actually have issues in scaling with the desires the customer has. So in this new world, it is not really the big fish which eats the small fish anymore. It's the faster fish which eats the slow fish. So it's small and slow. So yeah, the thing that company actually need to do now is to maybe come up with the same time to market or the same kind of rapid development kind of things the other companies are currently doing. They make that switch. And that's basically the reason why, at least from my company, we're also within the digital transformation, we're also looking at the IT side, because that's just a very important part in the transformation. If, by the way, if you have any questions along the way, just ask. I have a bit less time currently because the other talk was a bit longer because it started later. So I'll just go through it a bit more quickly. So one important thing I always try to confirm with companies is that you can basically say, okay, we currently have an issue, we have some kind of legacy stack, it's 10 years old, it's currently dragging us down and bringing new functionality to our customers. And they maybe want to rebuild everything and say, okay, we just hit the reset button, we build everything in a new kind of way. But the problem is, if you want to be fast, it's not just like the initial thing you should tackle. Being that adaptive in the current markets is not only time to market of new functionality, but it's also staying performant along the way. And if we just take a step back and like starting with software developments, who is currently doing Agile? I think everybody's doing Agile now, because before we were doing Agile, we thought, okay, maybe it's good to build software in some kind of waterfall kind of way. Seeing it as engineering, say, okay, somebody somewhere in the business had a set of requirements, somebody's going to take a look at those requirements, somebody's going to translate those requirements in this ivory tower as an architect, and then somewhere along the road there are people eating pizza and drinking coffee, and they will maybe translate those requirements into workable software. And for a long period of time they thought, okay, this is the way we should build software. We should build buildings with very good foundation, and we should be engineers. We should build buildings. But the problem is, I mean, if you have a building and you build just a very big tower, you expect that that thing will last in the same kind of state for the next couple of 100 years. But if you look at software, I mean, at the moment you're actually implementing the requirements, there's like the potential that the requirements already changed. So having one very rigid kind of structure in the way you develop software doesn't really work with ever-changing requirements. So at one point in time we said, okay, then we should have agility because we have to implement some kind of agile thing. We have to implement Scrum or Kanban because that will ensure that we, instead of a waterfall, we have a more iterative approach. We can just develop our software quite quickly. Maybe we can just push out new functionality every week. That's what the other cool guys in San Francisco are doing. So we implement this and then everything will be okay, right? But the problem is if you look at a system and the complexity of the system is when you start building a system, it's very good to have everyone aligned and say, okay, single system, collaboration is easy, you're basically working the same code base, you know what the other guy is doing, and for terms of alignment and training people within the company, this is actually helping. So in initial phases, I think that having a single code base can actually help in having a very good productivity. And then somewhere along, the complexity gets larger, you have a single code base, potentially multiple parallel teams because you were doing agile, working on that code base, and what you see is that, at least in my experience, that you come to a company and say, okay, we're doing agile, we're doing everything by the book, but still we have those problems that it just takes, I think, 2 or 3 months to actually get new functionality in line. And if you look at their sprint planning and say, okay, what is like the sprint you're currently doing? Is it 1 week or 2 weeks? No, we do 4 weeks because we need 3 days of alignment before starting a sprint. So we're just to have to make sure that somebody in this team is not changing something which can potentially impact the changes they do in that team. And then the end of the sprint, they're doing manual regression testing and merging everything. And that's a very big job because they should worry about how potentially multiple parallel teams are building on the same code base and that thing should end up stable. So what you see is in the end, with a single system, it actually gets harder to be as productive because it just, you need that much coordination. And this is basically the moment where we come in, normally as a company. So they say, okay, we have an issue, we cannot scale anymore, we're doing Scrum, we're doing everything by the book, so please help us. And they expect you to do this. So they build one big monolith and say, please put your demolition hats on, crush everything down and build something again and now do it good. And when you have the discussion, it doesn't really matter that you say, okay, what is like, how many times did you actually rebuild your stack? Well, normally it's like 2 or 3 times. So it's like every 4 or 5 years they're rebuilding and rebuilding, putting the demolition hat on, retrying everything again. And I think for me, and the main argument why, besides things like resilience and scalability, etc., why it's a good reason to look into microservices, is that it should have a different approach in tackling this part. So instead of like looking at your software as something which should be replaced in terms of a stack, that maybe you look at a different way towards your software. Conway once quoted, currently dubbed as the Conway's law, is that if you look in an organization, that they most of the times will build systems which are, well, a representation of their internal communication structure. So if you have a very rigid kind of structure, people yelling to developers, you should develop this now and you should deploy it next week, you don't have a lot of flexibility in that process, then potentially you will end up with a software system which isn't that flexible. And this is quite hard because, I mean, it's very hard to actually prove this law, but I think the dual is actually better. If you'd say, okay, an organization organizes itself around its own code base, the way it's developed. So if you have, like I earlier said, one kind of rigid monolithic structure, and you want to be very agile, you want to have parallel teams, you want to have teams building their software completely autonomous and deploying the software completely autonomous, that will actually be very, very hard if you cannot do that in your stack. So, taking one step back, we started with the fact that the companies want to be the faster fish, want to stay fast. So it basically means if you want to have high parallelization of work, you want to have actually, if you put more developers on a project, that you actually get more work done, then you should build software in a way in which you can actually take advantage of Conway's law. So that means if this would be your normal structure, you say, okay, start with a sprint, have a set of front-end developers, back-end developers, infrastructure developers, that if you're not changing the way you build your software, you have very much dependencies, coupling, and alignment between your development teams because it was necessary to do that within a monolith and you try to replace it with a microservice architecture. In the end, it's a very possibility that you end up with something, and I think Jonas started with the term, is the microlithic architecture. It could still be a microservice-based architecture, but it's still some kind of rigid tower. And what you often see is also, for instance, if you have a microservice architecture where everything is completely coupled and completely dependent on each other by, for instance, REST interfaces, is that it's still very hard to actually get that software online in parallel. So that still means that maybe you're doing microservices, but you need way too much communication and coordination here to test if it changes the API, that doesn't break somewhere along the way when you push things in production. And in the end, at least for me, if you look at companies which has actually done microservice implementation and weren't very happy about that and said, okay, we started with something, then somebody coined we should do microservices, now actually we have a situation which is even worse, is that most of the times the problem is that it's very hard even within that system to autonomously push your code. So what we want to do is to basically have a sprint, say, okay, we have a set of teams, we have a set of functionality which should be developed, and then somewhere along, somebody's going to fill in those domains in specific services. And then we can just deploy all those services again. So far clear? Any questions? There will be some code later on, but this is basically the introduction I want to get into. So I think the main question and the main arguments, should I do microservices, focuses around the idea that, okay, why cannot just do modular programming within a monolith, right? I mean, why should you introduce services and combine those with teams instead of like having one big monolith and say, okay, we have a modular architecture, I can bind those people towards those services? Is that the problem is that most software will also always be implemented under deadlines. So somebody says, okay, we'll start with some logical boundaries, we just have modules, and somewhere along the way somebody says, okay, you do not have a month or 2 months to develop this software, you would just have 1 week, and then somebody builds a bridge between two modules, they introduce some technical depth, maybe they document it, and then somewhere along the way, the next sprint, somebody says, hey, that's nice, a bridge, I'll just build a building on top of that bridge. And in the end, you will be in a situation where you have that much coupling and that much dependencies between modules that is actually quite hard to refactor it or still having that kind of parallelization in work. So for me, and the main argument for microservices is that you actually make it a bit more uncomfortable, if you do it right, to make those bridges. So instead of having a logical boundary, you can actually introduce something as an async boundary because you still have to communicate somewhere across the REST interface or whatever. So what I see is that if you start with microservices, yes, it's complex because you have to have service discovery, you have to have maybe message brokers, you have to determine how services are going to find each other, how they're going to store information. So when you start with a project, and I think that's also the reason why the terminology came like, okay, if you want to build microservices, maybe you should start as a monolith and just split out from there into several services. And this is the reason, because as you start, potentially there will be added complexity. But in the end, if you just venture on and your system will increase in complexities, what you see with microservices is that it's actually quite easy for a team just to work on a single domain instead of worrying what's happening in the other domains. So you have a level of localized complexity which will help your team actually building software a bit more easier, a bit more faster. So in the end, you will still have a lower productivity because you have a very complex system. But just to have multiple services and people can actually work on a single service, in the end, the overall effect is a bit lower. But then, of course, the question is, where do you start? I just said, okay, we could implement microservices, don't put your demolition hat on and whatever. And don't look at it as a stack, but where should you start? I mean, where do you start with implementing microservices? I actually seen customers which have done the 2 years route in implementing microservices, and the thing is currently still not online because you have some issues. Because first, the current legacy system is still earning money, it's still running, because if it's burning down, then you have another issue. So basically, they need to build a new architecture because reasons of flexibility and increased performance. But I mean, we're going to push it online. Maybe after 2 years, somebody's going to press the green switch. Well, most of the C-level management won't agree with that because they're a bit scared of introducing their main cash flow to a new system. You could also say, okay, we need a load balancer. Maybe we can just like 5 or 10% of our traffic will go to the new system and the rest will be in the old system. But the problem with that is that you need to have complete feature parity between both systems. So if functionality is being added here, then you also have to add it here. So basically, you're doing 2 tracks of development of the same functionality. So I think many, many years ago, there was a blue book written, and I think everybody pretends to have read. Who has actually have read the domain-driven design book by Eric Evans? Who pretends to have read the book? Yeah, there we go. So, the thing is, what Eric Evans states is that if you have a design of a system and it really doesn't map that well towards a model, then you should really question yourself if the correctness or if the software is actually correct. And that's the problem, I think, with most legacy software or software within businesses. Somewhere along the way, somebody just drove requirements and somebody built that in a single system. But if you go to a customer and say, okay, this specific set of functionality, so for instance the e-commerce environments, who's doing shipment and what kind of business logic is around shipment, then it's potentially somewhere here, somewhere there, somewhere there, somewhere there. So it's really hard to actually see what's happening there. And I think with domain-driven design, what we try to do is to middle business domains as technology. So saying, okay, if I have a separate part somewhere inside my business, then that should be defined as a separate domain somewhere in my code. So actually, people within the business, the stakeholders, the analysts or whatever, can communicate with one single development team. They speak all the same language, some kind of shared language, and they will end up building software quite well and quite understandable. And I think this is the base of agile software development, because basically what you can do here is that you say, okay, I have specific domains within my business, and within those domains I will just parallelize my work because one team will work on that, one team will work on that. So yeah, separate people, agile. So you should think, okay, domain-driven design could be the thing we need to actually implement software at a more rapid rate. So maybe going back to the default example, and I tried to come up with a different example, but currently a lot of my customers are actually in the e-commerce environment, so why not? If you look, for instance, at the normal kind of flow you have, somebody may create a shopping bag, send it to an order, and that order will eventually be shipped. If you look at it from a non-technical perspective, you could say, okay, there's someone somewhere in a shop putting things in a cart, going to a cashier and say, okay, I need this, I will pay this right now, and I need this delivered to my home, and then somebody has a van and he will ship the order eventually to the home. Nowhere in this neighborhood should be normally, in a normal situation, should be a lot of coordination. The cashier doesn't really matter, doesn't really concern about how the shopping bag is made. She's just concerned, or he's just concerned about taking items out of a shopping bag, checking if it's paid, and then it's done. The guy actually shipping that thing doesn't really care about the shopping bag or how the order was done. He only wants to know if it's been paid and what the shipping information will be. So if you look from a non-technical level, we already have a very high level of autonomy here. And what we try to do with domain-driven design is just to keep this autonomy also on a, well, technical level. So you could say, okay, I have specific domains, shopping bag, or a shopping bag domain, order domain, and shipping domain. So what is a domain exactly? Well, you could say that a domain is a sphere of knowledge, influence, or activity within the company. It should be a direct representation. And a lot of discussions with domain-driven design start with, okay, what is a domain? How far does that domain stretch? One thing I normally do is that when I enter a business and I actually want to see, okay, what are you doing here? I want to understand. You can do something like event storming to actually know what's happening within the business. But another thing is just to have a very analog version of doing that. It's just to say, okay, how would your business run if you didn't have IT? So I just give you a piece of paper and just go through your business flow, who's getting it on his table, and how do you call this departments. And then basically then you have the domain owners in which you should talk with, well, to implement your functionality. And within those domains, we have some kind of shared language between specialists and development. So we have a higher level of alignment between business and IT, and that's what we want. So as an example, you could say, okay, we have some kind of command, add item to shopping bag, which is an SKU, and it takes an amount. Some formatter here. We could say we have a case class, shopping bag, and that takes items, which is basically a map from the SKU here towards a amount. Int. If we look at the order, well, we could say introduce shopping bag here, but that automatically already results in the fact that we have slight coupling between those terms, and that is not very nice to do. So we could say, okay, we will create an order, which is some kind of command I want to send, which has a set of items, and both it's just a map of an SKU and a number, and we have to have some kind of formatter to do that. So in the sense of domain-driven design, we say, okay, this is happening. I can understand this. This is like normal, understandable things. If somebody, the business owner, would read this code, he would immediately know, maybe I could call this SKU, that would even better, and maybe make a microtype for int and say this is amount, but okay. Everybody understands this. So if you would like convert this to a service, you say, okay, well, then I have a function called add item to back, which takes a user ID. And this is some kind of service call in which I can send the command to get something back. And this is, by the way, a service definition within Lagom. And in this case, service call is just a function which wraps around another function which takes something and returns something. And it should be serializable, deserializable, and should be done something with HTTP. It could be sent over HTTP. And those things are pluggable. And then you have to say, okay, we need to have a REST interface and say, okay, I need to have a function or at least a path for add item to back, and I will do a get REST call and say, okay, there's another function, retrieve shopping bag. So this is service definition. And what you can do with Lagom is basically within the service call, you could say, okay, we'll send a command, it will send a reply. You could also add a source here. So you can use akka streams here and say, okay, I will take a source of items and then maybe return one response, or potentially even that you will take a source of items and return a source of items and maybe do some kind of transducing action within your server. So that's my shopping bag. I would say, okay, then we introduce the order service. We're going to align that with that domain and say we have a function called create order, which takes a user ID, takes a command create order, and then returns an order, or at least the current state, and we add a REST path to this. And just looking at this definition, nobody ever knows what actually is happening underneath, what the implementation would be. But most of the developers looking at this interface immediately know this is what's happening. Maybe if I just look at those case classes which are defined somewhere in an API package, then I really don't have to know how that is implemented. Basically, my complexity for this domain here stops here. So if you would have, for instance, so it stops there. So within domain-driven design, you have another concept called bounded context. And I think a lot of people are actually confused by the term. But in the end, a bounded context should be the same as domain, but it's more of a more explicit name of a boundary of a domain. So if you have, for instance, a front-end gateway, how could I call this service without ever knowing what the implementation would be of this service? Is they could say, okay, somewhere along there's a user who's going to take up his shopping bag and post it into an order, so I can actually create the order with the shopping bag information. And then within a service gateway, it could be play or whatever, I say, okay, first retrieve on basis of a username, retrieve my shopping bag, I will invoke that, and then somewhere in my order service, I will take this shopping bag, pick the items, create a new order, use this command, and then in the end, I can return this order. And this is the way how you invoke Lagom services. So it's basically only importing this interface and then just doing the invoke there, and then it's done. So this is basically a flow you could model between services. So you'd say, okay, if I just look at the side effects which could come over service, say, okay, I have an order domain. Somewhere in the domain something happens that the order has been paid, so it's ready for shipment, and then within the shipping domain maybe in the end the shipment is delivered. So in a sense we could say this is a way to implement that. So within the shipping service we say there's a function called start shipment process for order, which is a service call of a ship order command, which could be any command, and the service call will not give a return back, just non-used. And then we have a additional method here in the shopping service, say, okay, this is the way we can post this. So this is actually the default implementation I've seen in most microservice implementations. Say, okay, I'm a order domain. I want to know if the order is being shipped, so I will post my message towards the order, towards the shipping service. But this is actually not a very good idea. It's actually a very bad idea. Because basically what you do here is that you introduce something within the order domain that they should have knowledge about the shipment domain. And maybe that's not bad, because there is a higher level of alignment between maybe those two services or two domains. But the problem is what happens when this thing fails. So somewhere along in your service you say, okay, I just completed my order, I want to ship this order, and then the service is down, so I don't get a message back. So what do? You maybe introduce a retrier. What will you do if the retrier, even after 10 minutes, still isn't working? There you have an issue, right? I mean, maybe you need to build a scheduler, maybe you have to add an additional queue or whatever to implement that. And what you're doing now is basically the start of a lot of nonsense, is because then for every service calling another service or exchanging data, then every service should know where the other service is currently running. If somebody changes here this path, then that should be aligned with the other team, because basically you change the REST path, maybe that's changing something, maybe it's breaking something. So this is not a very good idea. And I think Russ Miles actually started this term, event first domain-driven design. So actually you have an addition on top of domain-driven design and say, okay, just like with shared state concurrency, and we actually like to do message passing because we're a Scala conference and we have a lot of ACK events, is what would this problem look like if we didn't introduce it in the first place? So could we define something in which we don't have some kind of synchronous behavior like this, but just introduce something where we do message passing and hope everything goes well? So somewhere in the blue book, there's a chapter and say, okay, of course you have domains and of course you have services, but nowhere in the world it's possible that a domain or a service will just function on its own. There should always be some level of communication between services to actually make a successful application. And just an ordering of overlap between, I mean, most of the systems which aren't scaling very good anymore, is that when you look at trying to explain what kind of domains are currently active in the system, you could say, okay, what is the relationship between those domains? Well, a big ball of mud. And that means that this is a relationship in which you actually don't know where the boundaries are, what the level of communication is, and potentially are in a whole lot of problems. And the other way, you could say separate ways, that's when there's no kind of any relationship left anymore, and shared kernel is if you're actually sharing code or something like customer supplier, you can relate to it, I guess. That's somebody says, okay, I will just supply you with information and this is just customer. So there are ways to model this, and it's very important to do this within domain-driven design and think about these rules. I'm not going to go through it completely because that's a different talk, I guess. So if we have like this kind of situation in which we say, okay, we will send a command, it was the first one, ship order, somewhere along the domain that will hit maybe on your HTTP service, and then that HTTP service will then send to the order maybe ship. Well, this could be anything, maybe a database record, maybe an actor, maybe an aggregate or whatever. And then eventually maybe an event will be produced and say, okay, order is ready to be picked. And this is not something technical. I mean, if you would model a business flow like this without looking at technology, it will have something like this, say, okay, go ship now, okay, sure, I will do it, and in the end, it's ready to be picked. It's like a normal communication flow. And like I said, if you have a retryer and say, okay, you're currently not available, and I'm going to retry and retry and retry, also within the team, that won't help. If you're actually talking to people, and also within a system, this won't work. So a better way to model this, just say, okay, somewhere along, I will do something and say, this order has been paid. I will just push the invoice on your table, and whenever you're ready, do your thing. And that's the thing we basically try to model with events first domain-driven design, is that we could say, okay, somewhere in our API package, we define a order event, which is an order ID, and then we have, in this case, 3 events: order created, shipment info added to order, and order paid, which are all order events. So what we could do instead of having that REST interface there is that we could say, okay, maybe we want to have a topic within our order service, which is basically exposing these kind of order events. So we say, okay, within our interface declaration, we say order events with the topic exposing order events. But we need something to model this, because you can do something like event sourcing. Maybe eventually some events will be generated here, but they should come from somewhere. And within domain-driven design, somewhere along the book, there's actually a definition of, okay, how can we, within a domain, if you have some level of isolation between domains because you have the bounded context, can I have the same level of isolation within a domain for specific parts of my system doing storage? I think the term has already been dropped quite some times in this conference, is that you could define something like an aggregate. Is everybody familiar with this concept of an aggregate? Not everybody, yeah? So the aggregates is, I mean, if you would map it towards an actor, you could say, okay, the aggregate is basically an actor. It's just taking a command, doing something, potentially doing a side effect, potentially doing nothing, potentially replying. But what you're doing there is that you just have a, maybe a group of associated objects. So maybe you have an order actor, which has the order lines integrated like this. And say, okay, this is just something, an aggregate or an actor, taking a create order command, sending back an ACK, and then eventually maybe doing something like sending out an event, which is an order created event. So if you look at Lagom and looking at how you to model a system like this, is that they actually added an abstraction on top of the persistent akka persistence. And that's basically a entity framework. So in this case, we say we have the order entity, which extends the persistent entity. We have some types which should override and say, okay, this current state of this entity is an option on order. And by the way, why is it P order and not order? Is if you have an API and you maybe expose either events, commands, or state from your domain, it's very good to separate the things you're storing in a persistence layer and things you're exposing to the API, because the life cycle of your API most of the times is a bit longer than maybe the life cycle you have internally. So you want to shield the potential changes you do here towards people consuming your service. So the initial state is none, so it's basically I don't have an order, and then you could define some behavior and say, okay, if the behavior is none, then go to the function called non-existing yet. If I have an order as a state and the order is not paid, then take the not paid behavior, and if all of this is true, then maybe do the order completed behavior. So I just defined here the not paid behavior. So this is event sourcing, and you have a segregation between the commands and events here. So it's a level CQRS. Say, okay, I have an action. Well, this apply isn't needed here. I can just use those. Say, okay, when a command comes in of type add payment to order with a reply type of done, then I will pattern match this. I will just accept it because I'm in the current state not paid yet. And if I had an add payment to order, here you could potentially do validation and return an error if something goes wrong here. But we just assume that everything went okay. And then we're going to persist an event, order paid with the payments, and then reply the done type here towards the person or the system or whatever calling our aggregates here. And then when an event comes in, for instance, the P order paid, then we will change our state that the paid status is true, so maybe it will happen somewhere here that eventually he will be in the order completed state. So what happens within Lagom is when a command comes in, you store this, then you reply it, and then eventually that event will be triggered here. So it's not synchronous. There's actually some time between here, and there's really no way to know if this event is being fired now because a command has been sent, or that event is being replayed somewhere along because you're just restarting the actor. So in that case, it's the same as akka persistence. So they have some kind of timeout on an actor, and if an actor dies or the aggregate dies because he wants not to retain old memory, then maybe after 1 minute he gets a new command in, then he's going to replay all of the events, then take in the command, and then potentially have that effect. So what you have here is that, like I said, the constraint within aggregates that we want to have one identifiable group of associated objects which we can ensure a single unit of modification. This works because we just have our consistency boundaries here. We accept our commands, we accept our events, we handle that. So we have these events happening here, and what we actually wanted to do is to just send those events along between services. So if you look at the way you actually can create entities, is that there's something within Lagom called the persistent entity registry, and that's basically the thing ensuring that actors can be spawned and actors can actually store their information. And what you can do is that within the persistent entity registry, you could request all of the events happening within that registry, so basically all of the events exposed by that aggregate, and based on one specific tag. So I say just get all of the order events which are happening within this registry from offsets, and then I convert this P order event potentially to some kind of API event, which I'm going to expose to other services, and I'm going to map the offset here. And why is the offset important here? I'll get to that later. But if we look at the subscriber, so this could be defined in the in the shipping service. We could say, okay, we have a subscriber. So for every event coming in, I will take a subscription on that, and for every order event, Akka streams. So if an order paid comes in, then I maybe have a shipment order with the same ID as the order ID. Maybe I align that so it's easy to communicate. And then say, okay, then you can ship this order because I just got the order paid events from the order service. And if something else happens, then I'm done. And here you can say, okay, for the persistent entity registry, I'm using it there. For this order ID, get this shipping entity specifically. Any questions on this? So why are those offsets important? The thing is, I mean, it's very nice that we have something like topics which can implement, use some kind of subscriber in another service to maybe retrieve those events. But what happens when a machine goes down? I mean, there could be an issue here, is that I want to maybe post my stuff to my message broker. Maybe I'm using Kafka, maybe I'm using whatever message broker I want to do. But like for instance, let's say we were publishing these events to Kafka, and Kafka goes down, then we have an issue. Because the reason why we introduce REST interfaces is because we wanted to make sure that events actually, or that command actually bridges the gap between boundaries. And now we're saying, okay, we're going to introduce something in which we have less dependencies between the services, but we should still have the same level of durability. So what you have here is within your event source system, basically you have a very large event log with a lot of IDs. And what you could do there is that you say, okay, somewhere along the way there's an offset. So this is my last message. And maybe Kafka went down, and then maybe along the way, somewhere in the background, the client is retrying to Kafka, and then Kafka comes up again. And it could mean that somewhere in my event log I have 50 new messages which hasn't been synced to Kafka yet. And there I can use just this offset and say, okay, we will start from the current state of the current offset which has been stored currently is being stored in the persistence layer, and say, okay, just start event streaming this to Kafka or once again from this offset. And every time I have a successful write to Kafka, then I will just up my offset and I know that this message has been written. And from the other parts, I could do the same, is they say, okay, I just have my order events and I'm going to consume those. And underneath, Lagom is using a committable source to implement this. So every successful future here, and that's why it's a map async, hoping to expect to get a future. So every successful future coming here, it basically commits it offset towards Kafka. So he knows that, okay, this is the message I've already been processing. And if a failure throws here, then the offset won't be committed. And then potentially if you have an issue somewhere in your service, you're not able to consume messages anymore, and you restart your service and Kafka has still 60 messages left, you can consume those at the moment you're online. So what we do with offsets, or what the purpose of offset is in this case, is that we push the durability concerns from subscriber to consumer. So instead of like pushing commands around between services, we could say it's the concern of the consumer to actually know where he is. So with the penalty of eventually consistency, we actually get autonomy. Because now we have a situation in which some team can just pull their service down, re-upgrade it again, and once it comes up, he will just replay all the messages currently on Kafka by using that offset, and he's online and running anymore. You don't have to implement retriers, there's no issue that the service went down. So it's actually easier to move that. The other thing is that somebody wants to change the interface of their domain, or maybe wants to split its domain in 4 specific domains. Nobody really cares, as long as somebody somewhere within your service is just still producing the same events. So in that case, you can actually have less alignment between teams to ensure that you can build that functionality. So there was a bit of an introduction towards domain-driven design and how the way Lagom is introducing that. But I guess I started the presentation on the ability of rolling out microservices not in a big bang kind of way, because that's a bad idea, because potentially you have to wait 2 years. But in a way in which you could say, okay, maybe we're going to introduce technology incrementally, maybe we can try things out there and maybe have business value from day one because we already have a new service up and running. So if you look back at the kind of domain view, you could say, okay, we have the order, shipping, and the shopping bag domain. maybe some relationships, here's a partnership, and maybe the items, the order domain gets conform, it just conforms with whatever the shopping bag service has. Is that from this level, it really doesn't matter who's implementing this. I mean, if you look at this view and say, these are the relationships, I do not have to know what kind of technology is driving this. So it could be that, for instance, I'm going to replace this part, I'm going to replace this part, but this part is just way too complex, but potentially still working. So what we could do here is to just implement an anti-corruption layer and say, okay, somewhere along the way, this shipping domain is talking some kind of different API I do not want to introduce to my services here. And then I have a translation layer in between, which is basically modeling my relationship the way I want to. So looking at the implementation, like the service implementation we had before within Lagom, if you have a REST interface, you could basically make an interface like that, and within the implementation call another service. You can import that package, you could just work around with it like it's just a normal service already written in Lagom, but you don't know because you really don't care, you just have to know how to find that service. Another way, if you want to have something in which you're just dependent on events, because that's the thing you want to do, maybe you will introduce something like a data pump in the anti-corruption layer and say, okay, my order domain is still going to expose my events, he's going to publish them, and here I'm just consuming those events and posting them directly to my old legacy shipment service. And then in my shipment service, if something is happening here, maybe on an ESB or whatever, in which you can combine it with Alpaca and say everything that's happening there, I would just push that onto Kafka. So with the anti-corruption layer, what we could do is that basically we can build our own ivory tower in the way once we have our architecture. And we will protect the legacy system and vice versa. So we're not introducing difficult parts of a legacy system into our new shiny microservice architecture, and we're not like trying to change the legacy system to fit into our current microservice architecture because maybe we don't want to do any work there anymore. So Lagom, they say, okay, what's the translation? Well, right fitting, neither too much, neither too little. And I think this is the reason why Lagom works quite well, is that, at least for me, that Lagom provides a very opinionated way of building microservices that constrains developers in the choice they want to make. So basically the discussion I just had, thinking about domains, thinking about pushing events along, this is what you get out of the box. And if you want to go outside of that box, potentially it will be uncomfortable. But it will actually help in getting the right rules and the right constraints right the first time if you want to start building microservices. And one of the biggest advantages is that actually Lagom, if you have all of the services in a monorepo, you can just do a run all. It will spawn a Kafka instance, a Cassandra instance locally. It will spawn a service coordinator, everything on your single machine. So maybe you have multiple microservices which you're going to deploy to the cloud or whatever. You can just build your complete microservice architecture and run that locally with continuous compilation. So if you change something here and you change the API, you can actually test that. So like I said, maybe that's a bad idea, but what we can do then is, if you have that activity complexity graph, is that in this case, within Lagom, we can just build everything as a monolith, but it's still modular because we just have multiple modules only talking through some kind of API interface like we see before with each other. And maybe after this part, I'm just going to split those up, not use a monorepo, maybe different repositories, and I'm going to develop and deploy it separately. But the nice thing is that basically you get both, a best of both worlds. So just a quick scan what you actually get back from Lagom. So Lagom has an aggregate framework based on Akka persistence. So that means that currently comes out of the box with Cassandra support and for most SQL databases. But if you want to add an additional driver and you have an Akka persistence implementation already for that specific database, then it's quite easy to do that. You get event sourcing CQRS framework out of the box. Yeah, get a message broker API out of the box with a default Kafka implementation in which you can, well, do domain event sharing. And this all also runs on your local machine if you do the run all. If you want to share aggregates, currently they're using Akka cluster, the sharding framework. So every entity is already, if you have multiple instances or multiple servers running a domain, those aggregates will automatically scale. So this is a nice thing, because if you want to do that something like Spring Boot and you want to implement a microservice architecture there, and you want to maybe use Axon to implement this, actually scaling that out and having that resilient is quite difficult. This comes out of the box and quite easy and quite understandable if you know the akka stack. And you have a service discovery which is completely pluggable. So I think a lot of negative things came from the fact that people thought that Lagom will only run in Conductor. We're currently running it in Kubernetes and Mesos both. And actually at a company at CBA, we're currently looking into having a way of running Lagom completely into the Google Cloud and also using the data store there. So I think for me, and why I'm actually using Lagom at some of our clients, is that it are your training wheels in moving away from the monolith, and it enables you to actually make your end goal your first delivered project. So when your end goal was we need to have additional complexity, more performance in our software development process, then using an incremental approach like this with Lagom ensures that maybe in 2 or 3 weeks you have refactored one service, retrofitted in your current system, and then potentially you have a better environment to incrementally build a software in a better and more performant way. So I guess there was a lot of information in 45 minutes. Does anybody has any questions?
I'm sorry,
we don't have time for questions.
Yeah.
Okay, sure. So just hit me up if you have some questions on Lagom or thinking of implementing that, and I can help you.